Hi, I want to give a small update about a very old project I am working on. But as you know, I am a little bit very interested in different subjects, so I'm moving away and coming back. In 2018 or 2019, I built a Z180 from Zilog based microcomputer, and I have a first prototype running on here, and I name it Capri Z180. And now I want to come back to this project, and I want to think about a keyboard for it. And I have bought some refurbished keyboards from old laptops, and I need to have a kind of controller, and I want to use an ATMega to make a keyboard controller, which then speaks the output to the Z180 Capri board. And in addition, I'm always looking or thinking about in which case I should build Capri into it. And I like the case from CPC 6128 Plus. It looks beautiful beside an MSX one. Okay, you know, I'm a little bit in favor of MSX, but this case is beautiful. And I have bought this case, an empty case, a few years ago from a flea market for some euros. And a keyboard encoding, I said, I want to try to program in C for the ATMega. So the basic concept of the thing is the following. We see on here the prototype, the first prototype of the Z180 computer, and we see on here the case from the Amstrad CPC 6128 Plus, and we see on here also a refurbished keyboard. I like this one as it does not have the Windows logo on, and as it has also a German umlaut. And it seems that this thing is organized in 8 rows by 16 columns, and these are these two flat cable thing on there. So I need something to connect this one to this one, and then this is all the idea or the task. So this is the task. For power supply of this thing, I have not been thinking yet, but I will buy something very slim, which is connected straightforward to the mains and creates the needed power for this beauty. But as long I will go and I don't have a power supply, I will use the following. I want to use my Zoba box. A Zoba box is this orange box. It contains a power supply, RS-232 terminal from Mr. Graham, Graham something, Graham, something like this, with a composite output. And I reused a screen you can find in cars. If a car drives backwards, you have a back cam, and the video signal of the back cam is displayed in the cabin of the driver. So this is something like this. I put this onto this box and a small breadboard, whatever. And this thing on here, I tested it with an MSX in before, is a composite input. And in the inside of the box you see the power supply, which creates 1, 2, 3, 4, 5 different voltages I showed this in one movie, and internal adapters to connect additional boards with power. I have a few of them, and one goes also out. One of these goes also outside, and this is this pigtail on there. There is the connector, the plug, which comes onto like this. On here you see also the from Mr. Graham. I cannot read it. Arnold Graham. He made this, and and he offered this on his website. I will add in the description. I cannot read and I cannot remember. He has the circuit on his website and also the hex file for this PIC microcontroller, and this I soldered onto this PCB thing on there. And within this box Capri is living, and Capri is the Zilog Z180 microcomputer 2019, and you see on here the processor, glue logic in a GAL 22V, I don't know, 8 or 16, I don't know, and memory ICs. On here you see a serial interface, is a level shifter. You see on here a bus master for I2C, so the Zilog. I mapped the bus master in the I/O space of the Zilog, and on here a small clock, real-time clock with a battery to it, capacitor, long living one, and some, I think this is an 1x8 something, and a reset button, and a switch to change the clock rate. Sorry, I'm always clicking. But I messed up on here the footprint, so I had to move out the connected wires to here to a separate board, and I did this on here. You see on that side, the back side of here. Here I moved the wires out because I have mostly of the signal on here. I have also on this pin header on there, so it was easy to connect. So I put on here the wires, and just for a few I put there. So, and for this thing I want to have a keyboard, and I have bought two keyboards from refurbished laptops, and they are both organized 8x16. So I kept my focus on this arrangement of matrix. In 2015, actually, I played around with an ATMega128 and with an I2C and bus extender thing. These 4 pieces are bus extender, 8-bit wide. So this is 32-bit wide, connected via I2C to the ATMega on there. And these 32 bits are on here. I was thinking somehow to use this one and connect to there, but as these are flat cable thing, it's very difficult to connect these wires to there. So I made a PCB on here. I will come later to this. And these keyboards look quite the same, but they are not. They are German, umlaut on here and on here. But for example, on here, the number 1 left from it is nothing, and on the lower one, on the left from the 1 is this circle, this degree circle, and this power symbol. And this key can be found in the upper keyboard on there, see? Or on the other hand, right from this space is this key, but on the lower one, right from the space is Alt. See this? So it's a little bit different, right? So even if they are organized the same, the arrangement is different. So this means that the key code somehow, I don't know, would be different. Yeah. And they are also different in mechanics. The lower one have 1, 2, 3, 4, 5, 6, 7, 8 of these receptacles where you can use screws to mount it somewhere. The upper one only have 6, 1, 2, 3, 4, and in the middle and on that corner one. So I put these two things in a CAD tool, free CAD, and I measured it and I put the plates on there and the holes, and you see that even the mounting holes are not always aligned 100%, you know. Yeah. So it's very difficult to reuse refurbished parts in a project. You know. This is a kind of challenge, right?